Okay, MCT4C, lesson 1.2, part 2. We just talked about the cast rule, but the example is we've got a point on a terminal arm of a rotation angle, and we're supposed to determine the exact primary trig ratio. So again, just like any other trig question, let's start by drawing a diagram. And this isn't going to be perfect, 6, -3. I'm just going to sort of estimate, guess where it is. +6 is out here somewhere, -3 down here. So something like that. Call that P. And then this is theta then, that rotation angle. And I can see the terminal arm ends up in quadrant 4. So by the cast rule, or the all soup turns cold rule, we should know that only the cosine is going to be positive for this angle theta. Okay, and we'll see that that's in fact the case. All right, well, let's write them down. And sine theta equals cos theta equals tan theta equals. Well, this isn't one of our special triangles, I don't think. +6 there, -3 over here. Notice the sine is opposite over hypotenuse, but we don't have the hypotenuse. So let's find it. There, we'll call it that r. Then r squared is equal to 6 squared plus -3 squared. It's supposed to be a 3. A little more room. 45. And so r is the square root of 45. And again, I'm going to leave that as exact. Why not? Don't need a calculator. So the sine is opposite over hypotenuse, -3 over the square root of 45, and I don't care what that is, nor do I care what theta is. It doesn't ask for theta. Cosine is adjacent over hypotenuse, 6 over the square root of 45. Tangent is opposite over adjacent. Simplify that one, why not? And we can see cosine's positive, sine's negative, tan's negative. Cast rule made sense. We predicted that. All right, off. Oh, no, we got more. This is just a general case of what we just talked about. For any rotation angle theta that has xy on the terminal arm, sine is the y coordinate over the hypotenuse, or r for radius, and cosine is x over r, and tan is y over x, and r is just from the Pythagorean theorem. You know, x squared plus y squared equals r squared, but we take the square root of both sides, so we can write that little formula down. And notice that the unit circle is just a special case where r equals 1. Pairs of related angles are angles that have the same reference angles. Related angles have the same trig ratios, but not necessarily the same sine. So we were talking about that in a 3-minute review, weren't we? We said, you know, the sine of 45 was one of our special angles from yesterday. That was actually equal to the sine of 135. 135 and 45 were related angles because they both had a reference angle of 45. We also said sometimes we have to worry about the sine, because it wasn't the case that the cos of 45 was equal to the cos of 135, if you remember that from the 3-minute review, because this one's negative, right? The cosine is negative in the second quadrant where 135 ends up. Next. If cos x equals -3/8 and the terminal arm of x lands in quadrant 2, find the exact values of the other two. Well, this sounds very much similar to the one we just did, but let's draw a diagram. So we know it's in quadrant 2, so it's over here, which makes sense. Cosine is negative there, isn't it? Remember the cast rule. The cosine is going to be negative in this quadrant, but it could be in this quadrant too, but it said quadrant 2, so we'll draw that there. This is x right here. This is the rotation angle x, and now we can build our triangle. The question is, this isn't one of our special angles, so how do I use this to draw this? Well, cosine is still adjacent over hypotenuse. This is still 3. The hypotenuse is still 8. Negative because we're moved left, and then this is the side we don't know. We don't know the y-coordinate, do we? So I'm going to find it out. Pythagorean theorem. Subtract 9 from both sides. What's that? That's 55, I think. Square root. And then sine of x is the opposite side over the hypotenuse. Well, the opposite side now we said is square root of 55. Don't care to write that as a decimal. Over the hypotenuse is 8. Tan, and we know the tan is going to be negative, right? Cast rule, so only the sine's positive here. Opposite over adjacent. Square root of 55 over negative 3. Negative. Don't need to simplify that any further. Is that it for that one? Okay, on we go. If 2, 5 is on the terminal arm of an angle alpha, draw the diagram. Okay, well that doesn't seem so bad. We even got a grid this time. So 2, 5. Let me get a different color here. There's 2. 1, 2, 3, 4, 5. There's 2, 5 right there. That's P. And there's the terminal arm. We know all the ratios are going to be positive. It's in the first quadrant. So this is alpha right here. There's alpha right there. Draw a diagram, determine the trig ratios for alpha. All right, so, oops, let's start with sine, eh? Oh, we don't know the hypotenuse, do we? R equals 2 squared plus 5 squared, and I'm going to take the square root of that at the end. Square root of 4 plus 25, square root of 29. That's the hypotenuse. So sine of alpha is 5 over the square root of 29. Cos of alpha is equal to adjacent over hypotenuse, or the x-coordinate over the hypotenuse, and the tangent is good old 5 over 2, y over x. That's not it. Can't be. Aha! Determine the coordinates of points on the terminal arms. Angle A, that's 180 minus alpha. 180 minus alpha would mean, there's 180, would be here. So 180 minus alpha would be an angle A that's in quadrant 2. Would be here, right? We don't want to mess up our diagram too much, but what would be this point here? 180 minus, well, the x-coordinate is to the left, negative 2, and then the y-coordinate is the same. X-coordinate is negative, y-coordinate is the same. This one, 180 plus alpha, so this would be if the reference angle was plus the 180. So down here in the third quadrant, right? Well, both the x and the y coordinates would be negative then, wouldn't they? And then here, angle C angle C would be 360. Let me get another color here. 360 minus alpha. So alpha would be there, and this would be C in the fourth quadrant. Notice the x-coordinate would be the same, and the y-coordinate would be negative. This is a bit of a mess, but all they're asking for is this point, so good. Is that it? That's all they asked for. Notice that if we wanted to, how would the sine and cosine and tangents change for these points? Well, we can see here, let's, for example, this last one, the tangent of C, y divided, well, it's going to be negative. The cosine will be positive because the x-coordinate's positive. The sine will be negative because the y-coordinate's negative. And everything else, the numbers themselves, would all be the same, positive or negative. So for instance, the sine of C, well, it's going to be negative 5 over the square root of 29. That value, but negative since it's in the fourth quadrant. And so we could get ratios of other angles as well. And that's it.